Will society survive forever? Or will nature reclaim the earth for its own? Days rush by and fast forward as man tries to conquer nature. But Mother Nature wants revenge. New threats have emerged. The displaced and deceased creatures of the forest gave rise. The undead evolved to tear down all that humans have built, and craving each living human's flesh. Individuals huddle together for mutual protection from the horde, forming groups large enough to deter a zombie attack. Networks of roads have connected their cities as they sought each other, crossed paths, and met. Emergent structures can be observed in their paths. Spreading forests distribute all their new saplings and seedlings to try to stop the players' union. Cities thrive so long as the villagers live, but wherever they fall, the grass and trees creep in and retake their former territory. Each forest has a mind of its own, maximizing a goal of spreading towards the largest and most developed villages until they are completely overgrown. We chose an online method called particle swarm optimization for our terrain's machine learning algorithm, because it's trying to solve a search problem as it spreads. It's finding good local minima in a non-linear landscape of unevenly concentrated villages. We treat each terrain object as an independent agent, a particle capable of spreading in any direction using a special swarm heuristic. Its choice factors in random noise and the positions of the biggest villages found so far, both locally to this terrain object and globally to all terrains, two potentially different locations on the map. This weighted sum is computed in Lua, and the locations and value of sizes of nearby buildings is added up in a flow graph.
Whenever the terrain finds a global maximum, a village larger than any of the terrain objects have seen before, a few things happen. The terrain can try to spawn to a tornado in its effort to destroy the biggest village it knows of. The global maximum is written to an XML file, accessed by all the spreading terrain objects, so they can share its value to influence their search. These locations and scores are data that we log over time and graph out to give a picture of how quickly the AI converges to a solution and how good a job it thinks it's doing with its attacks. The forests, the weather, and the zombies all cooperate to knock down every building and expose the villagers living within. By following this search heuristic, the terrain follows the villagers' actions. Without having enough information to copy them outright, only the locations of what it has bumped into and how big of a building it was. It builds a structured forest in roughly the same pattern as the village by making roughly the same decisions as the player regarding where to go next, following the markers it leaves behind. Meanwhile, the player's flow graph detects displaced markers nearby and upgrades them to a larger building inside Lua.
Each run gives us different, non-reproducible, emergent paths that shape the terrain. Some runs work better than others, depending on if the humans get tripped up by their own creations and stuck inside of them. The inspiration for our game comes from sandbox games like Minecraft, where the map is computer-generated. In this case, we additionally let the AI creatures that inhabit the world shape it. Our game explores the interaction of AI and environment. To take advantage of Lumberyard's assets, we opted to not use arrangements of 3D volumes or blocks of material. instead using progressively taller structures placed atop the plane.
AI on AI interaction drives more complex AI behavior and more complex paths that show up in the terrain. We made an AI food chain with the undead above players in the hierarchy. The players must skillfully adapt to zombies' threats and hunger using their stamina attributes and grouping behaviors, which all factors into the paths they choose. That's all to say about the terrain AI. We hope you've enjoyed our video.